Today we are going to see this chapter called Geometry. So this is one of my favorite topics. I enjoy teaching this particular chapter. There are so many formulae in this. You have so many videos online, bits and pieces, small videos considering this particular topic. It's a very big chapter. So I'm not going to give you bits and pieces. I'm going to give you the whole basic concept information about geometry. It will last for around 2 to 2.5 hours, I guess. I'll try to cover the entire concept of geometry, starting from the basics until the higher level. Let's start. Geometry. First thing, we should know about the angles and lines. Say if I have a straight line, this whole angle is considered to be 180 degrees. Right, if I have center. Now, if I just have multiple lines over here, this entire angle, say if this is x, this is y, this is z, sum is going to be 180.1. Next, say this we call, if this angle is theta, right, this angle should be 180 minus theta, right? They call it as linear property. Let's forget those names. You are just you should know those things. I'm not going to go to the school level of thing naming all these things. You know this. So if that is theta, linear property, this is going to be 180 minus theta. Correspondingly, this has to be theta, because in this straight line, this whole will be 180. Therefore, this will be 180 minus theta. So these two angles are equal. So they are called as vertically opposite angles. Okay. So vertically opposite angles are equal. Next, if you have two parallel lines, say I have two parallel lines, these lines are parallel and intersect, and that is intersected by a transversal. This is called as a transversal. Here, as we know, these two angles are equal, vertically opposite angles. So if this is theta, this has to be theta. Similarly, these two angles are also equal. They're called as corresponding angles. So here, this will be vertically opposite. So all these four angles are equal. They name it. So these two are corresponding. Say if this is angle 1 and this is angle 2. One, 2, 3, 4. So 1 and 3 are vertically opposite. 1 and 2 are corresponding. 2 and 3 are alternate angles or alternate interior angles. 1 and 4 are alternate exterior angles. These are the different names. So therefore, the other angles what we have here, say this, say 1, 2, 3, 4, say 5, 6, 7, 8. All these angles will be equal to 180 minus theta. Clear? So two parallel lines intersected by transversal, these angles are equal. Next, we'll step into triangles. Before that, say when I say three parallel lines, right, intersected by two transversal like this, you have something called as intercept concept. So what is intercept? So here, this ratio, see if this length is A and this length is B, that will be same as this ratio. If this is C and this is D, right? So two parallel lines intersected by two transversals, the ratio of this A by B is equal to C by D. Intercept concept. Okay, this is number 3. Now we'll enter into triangles. So as we all know, sum of the angles in a triangle is 180 degree. Say consider any triangle. Okay, sum of the angles in a triangle is, sum of the interior angles, all three angles will be 180. Angle sum property. Why? If I ask a question, just let me just take you through this small derivation. Why the angles in a triangle is 180? Why it's 180? Say, let's consider two parallel lines like this. Okay, two parallel lines intersected by a transversal. Now we know these two angles are equal, right? So if this angle is x, this angle is also x. Right? Now let me consider another transversal like this. In this transversal, can I say these two angles are equal? If this is y, this will be y. Right? So now this is going to be the common angle. This angle is z. We know this angle x plus y plus z will be 180 degrees. Therefore, we have x plus y plus z is 180. That is why sum of the angles in a triangle x plus y plus z is 180. So coming back to this. So in this triangle, let me have these three angles. Say x, y and z. I am extending this side. Right? And let me say this angle will be 180 minus z. Right? So I know in this triangle x plus y plus z will be 180. Right? So what is 180 minus z? Will be x plus y. Right? So 180 minus z is nothing but x plus y. So in a triangle, my external angle is equal to sum of the interior opposite angles. Just good to know this concept. Okay. Now, so when I say triangle, you will have three sides. So triangle is a polygon with three sides. There's a condition with what sides will form a triangle, or the lengths based on the lengths. So in any triangle, if the sides are ABC, if the sides are A, B and C, okay, sum of the two sides is always greater than the third side. In a triangle, the sum of the two sides is always greater than the third side. So A plus B is more than C, B plus C is more than A plus C is more than B. Sum of two sides greater than the third side, as well as difference between the two sides is less than the third side. Okay, the difference between the two sides is B difference of C less than A difference of C less than B. Okay, why? If I just tell you, say let's consider two straight lines. Let me say two lines. Say this is 5 centimeter and say this is 7 centimeter. Okay, now please imagine I have a 5 centimeter line and a 7 centimeter line. Okay, so if this is 5 centimeter and this is 7 centimeter, right? So if I just join these two, 5 and 7, so my third side, please remember, my third side can be as close as possible. So if these two lines are straight, it will be like this. My 5 and 7 will be like this. 5 and this will be 7. I can't form a triangle. For me to form a triangle, I should have some angle between the two lines. I have a point from a point. So these two lines should have some angle. Only then it will form a triangle. If this angle is 0 degree, it will be a straight line. So if this is 7 centimeter and this is 5 centimeter, this length, the third side, okay, when this 5 is as close to 7, it will be slightly more than 2. If it's a straight line, 5, this portion is 2 centimeter. Right? Therefore, when I say two straight lines, if this straight line is here, a 5 centimeter line and a 7 centimeter line. Now, if this is lying on this line, I will not be able to form a triangle. Therefore, for me to form a triangle, this line should have some angle from this point. Should be some angle, theta should be there. So 5 centimeter. So this can be a third side. Now, when this is as close as possible, when this is over here, this centimeter is 2 centimeter. 2. This particular, when this is 5 centimeter, this is 5. Whole is 7. So this portion will be 2. Right? Since I need some angle, this length will be slightly more. So when I have something, so this length should be definitely more than 2. Right? So what can be the maximum possible side? So I have a 5 centimeter line and I have a 7 centimeter line. Right? Now, if I have to find the maximum value, this side 5 centimeter, this is 7 centimeter. This 5 centimeter, if I'm having it over here, okay, still it's a straight line. So I need this angle should be less than 180. If it is 180, it's a straight line. If it is less than 180, it will not form a straight line. So 7 centimeter. So this can form a triangle. So 7 plus 5 is 12. If it's 180 degree, it's going to be 12. So it's less than 180. It's slightly less than 12 centimeter. That is why the length of the third side should be less than 12 centimeter, more than 2 centimeter. That is why we have the third side is less than the sum and the third side is more than the difference. That is why we have sum of the two sides greater than the third side, difference of the two sides is less than the third side. Please remember this, okay? Next, let's get into the types of triangles. So what are the types of triangles? You have based on equal sides and based on the angles present, equal sides and equal angles, or based on the angles present. So when I say based on the sides or based on the angles present, you have acute angle triangle, right angle triangle, and obtuse angle triangle based on the angles present. So what's an acute angle triangle? In a triangle, if all the, so basically when I consider any triangle, sum of the angles is 180, right? So any triangle, sum of the angles, let's say angles are ABC, A plus B plus C will be 180. Sum is 180. Since the sum is 180, can I definitely say two angles are strictly less than 90? There can be only one angle. There's a possibility for one angle to be more than 90. Am I right? Or equal to 90. I can never say two angles are more than 90, right? Because 180, half of 180 is 90, right? Two angles cannot be 90. Because 90 and 90, third angle is 0, it will not form a triangle. Therefore, if one angle is more than 90, other two are less than 80, even if all three angles are less than 90, it can form a triangle. Am I right? I cannot have two angles that are more than 90. Therefore, can I definitely say among three angles, two angles are definitely less than 90, right? The third angle, the greatest angle, okay, that can be equal to 90 or less than 90 or more than 90. Therefore, when I say triangle, say, let me say here A greater than B greater than C, the angles, okay. So the B and C, the two smaller angles will definitely be less than 90. This greater angle is there, right? A, it can be less than 90 or equal to 90 or more than 90. Now, if this greatest possible angle in a triangle, if it is also less than 90, okay, if the greatest possible angle, so here A is the angle, if A is less than 90, right, it's called as acute angle triangle. If A is equal to 90, the greatest angle, it's called as a right angle triangle. If A is more than 90, is called as obtuse angle triangle, right? So if you just observe, the other two angles B and C will definitely be less than 90, right? So I am dealing with only the greatest angle. So the definition goes like this, or the understanding: in a triangle, all three angles less than 90, you can say that two angles. So I need not say that because I know among the three angles, two angles will definitely be less than 90. So the third angle, the greatest angle, if it is less than 90, it's acute. If it is equal to 90, it's right. If it is greater than 90, it's obtuse. This is based on the angles. Now, based on the equal angles in if sides are equal, angles are equal. So you have three types of triangles. So when you have three sides in a triangle, right? If all the three sides are equal, the three angles will also be equal to 60 degrees, okay? In a triangle, if all three sides are equal, definitely all three angles will be equal. It's called as an equilateral triangle. Right? Equilateral triangle. Now, if two sides of a triangle are equal, these two sides are equal, this is the unequal side. So their corresponding angles will also be equal. So these two angles are equal, this is the unequal angle. Okay, it's called as an isosceles triangle. If all three sides are different, all three angles will also be different. It's called as a scalene triangle. So based on the equal sides or angles, all three are equal, it will be equal to 60, equilateral. Two sides are equal, two angles are equal, isosceles, all three sides are different, all three angles are different, scalene. So in an isosceles triangle alone, so generally in any triangle, you will have three sides. Those three sides can also be called as bases on which it rests. But when I mention the base of a triangle, it can be any side. Only in an isosceles triangle, when I mention the base, the unequal side is called as the base. Please remember, in an isosceles triangle, this unequal side is there, right? That is called as the base, and this unequal angle, okay, is called as the vertical angle. This name applies only for an isosceles triangle, okay? So, in isosceles triangle, the unequal side is called as the base, and this unequal angle is called as a vertical angle. Other triangles, I can have any triangle as a base, any side as a base. All the angles can be called as anything. There is no specific names. So here only you have vertical. When I say vertical angle, it's the unequal angle. When I say base, it's the unequal side. Next. In a right angle triangle, let me consider the smaller sides as A and B and the greater side is C. Okay. So, we have a theorem called Pythagoras Theorem, which says A square plus B square equals C square. Okay. So, in a right angle triangle, A square plus B square equal to C square. So, this everyone know. So, same thing if I have to extend to an acute angle triangle. Okay, so this theorem is called as Pythagoras Theorem. Sum of the squares of the two sides is equal to square of the greater side. The greater side is called as the hypotenuse. So here in an acute angle triangle, let's say it's ABC, ABC. Let the smaller sides be A and B and the greater side be C. Let's have like this, okay. So here, if I say A square plus B square and if I have to compare it with C square, let's take these sides, I am freezing it, A and B. Okay, so I know A square plus B square is equal to C square. It's a right angle triangle. If I have to make it as an acute angle triangle, can I say the length of C is decreasing? A and B remains the same. The C is actually decreasing. So my A square plus B square will not be equal to C square. My A square plus B square will be greater than C square. Right? So if it's an acute angle triangle, A square plus B square is greater than C square. Same thing if I go for an obtuse angle triangle with same A and B. Right, smallest, if this is A, this is B, I can assume the larger side is C. So here, A square plus B square, if I'm comparing it with C square, so I'm freezing the same A and B, right, I'm extending. So this is AB for right, this for acute, this for obtuse. So my length of C is increasing, therefore A square plus B square will be less than C square. Okay, so when the sides ABC are given, sum of the squares of two sides equal to square of third side, it's right angle triangle. Sum of the squares of two sides is more than the square of the third side or the greater side. It's acute angle triangle. Sum of the squares of the smaller sides is less than the square of the longer side. It's obtuse angle triangle. Okay, based on sides. Now, let's consider this triangle ABC. Right, it's an acute angle triangle. Okay, now AC square, we know AC square is less than AB square plus BC square. AC square is less than AB square plus BC square. Right? So how much less? My AC square is less than AB square plus BC square. So how much less? It will be less by 2 BCBD. So here twice. What is the BCBD? So you drop a perpendicular D. Okay, AD is the perpendicular. Now AC square is nothing but AB square plus BC square minus 2 BCBD. Right? For acute angle triangle, AC square is nothing but AB square plus BC square minus 2 BCBD, where D is the perpendicular dropped. Similarly, if I apply the same thing to an obtuse angle triangle, ABC, for an obtuse angle triangle, AC square is equal to, that is actually more. So AB square plus BC square plus 2 BCBD. Now what is this BD again? So what is this D? D is nothing but the perpendicular dropped. Okay, to the base. So from A, you drop a perpendicular. I should extend this. This portion is D. Right? So BC is this portion, BD is this portion. Here BC is this portion, BD is this portion. So it's good to know this For rectangle triangle, AC square is AB square plus BC square minus 2BCBD. For obtuse angle triangle, AB square plus BC square plus 2BCBD is AC square. Okay. Now we are stepping into, maybe I can say, slightly higher level, which is going to be geometric centers. Till now we just saw what is the basics of parallel lines and triangles. Now we will see geometric centers. Okay, there are four geometric centers. You would have heard these names. You have something called as centroid. Then you have something called as incentre. Then you have something called as circumcentre. Then you have orthocentre. Okay, now what is this centroid, incentre, circumcentre and orthocentre? Centroid is nothing but intersection of the medians. Centroid is intersection of the medians. Incentre, intersection of the angle bisectors. Circumcentre is intersection of the perpendicular bisectors. Orthocentre is intersection of the altitudes. Okay, centroid, intersection of medians, incentre, intersection of angle bisectors, circumcentre, intersection of perpendicular bisectors, orthocentre, intersection of altitudes. Now, what is median, angle bisector, perpendicular bisector, and altitude? Let's see that one by one. Median. What is a median? So, median is in a triangle. If you have to just construct a median, you take the midpoint of the sides. So for any triangle, okay, you take the midpoint of the side, join to the vertex. It's a median. Okay, so median divides the side into two parts. Okay, so from this vertex you join. This is median. So these two sides are equal. These two portions are equal. So from this side, from this vertex, join here. So these two portions are equal. Right, and the third median from this vertex, it will pass through this point. These two portions are also equal. This point of intersection is called as the centroid, which is generally denoted by G. Okay, centroid is nothing but intersection of medians. Median, you have the midpoint. Three sides will have three midpoints. Just join it to the opposite vertex. So you have three medians for any triangle. The point of intersection of any two medians is called as centroid. So three medians will also intersect at this point. The centroid is nothing but the center of gravity for a triangle. Okay, for any object you have something called a center of gravity, right? At that portion, center of gravity in physics. Okay, so circle, the center of gravity. For a square, the intersection of the diagonals. For any object, so for this pen, you will have a center of gravity. For a body, we have. So every object, for this pan, you have center of gravity. This center of gravity for a triangle is called as the centroid. Okay, now, so there are certain properties related to median. So now, first point, centroid or the median, one median divides the triangle into two parts of equal area. First thing, right, median divides the triangle into two equal parts. Okay, one median divides the triangle into two equal parts. And point number two, the three medians, okay, three medians divide the triangle into six parts. Am I right? Of equal area. Right, so here we have six parts. Which are the six parts here? So 1, 2, 3, 4, 5, 6. All these parts are equal in area. Clear? Right? Let me just have this thing. Okay, right? So one median divides the triangle into two parts of equal area. All three medians divide the triangle into 6 parts of equilateral. That's point 2. Now point number 3. My centroid divides the median. Centroid divides the median in the ratio 2:1. So if this portion is 2 parts, okay, right, this portion is 1 part. From the centroid to the vertex will be twice that of the distance from the centroid to the other base. Okay, so this will be 2:1. My centroid divides the median in the ratio 2:1. Similarly here, this portion is 2 parts, this will be 1 part. Similarly here, this will be 2 parts, this will be 1 part. Okay, so if this total length is 3x, it will be 2x and x. 3y, 2y and y. 3z, 2z and z. Okay, now the fourth point, Apollonius Theorem. What is this Apollonius Theorem? Let me take this triangle ABC and say AD is the median. Okay, now AB square plus AC square. Okay, please note this carefully. AB square, this side, plus AC square is equal to twice of AD square, length of the median, plus BD square. This is my Apollonius Theorem. So AB square plus AC square equal to twice of AD square plus BD square. Just an extension of this. This theorem can be applied to all the 3 sides. It is useful in finding the lengths of the medians. Okay. Now have triangle ABC. Let me say the 3 medians. AD is the first median, BE is the second median, and CF is the third median. Right? So extending this Apollonius theorem here. So considering this length AD, median AD. So we know AB square plus AC square. AB square plus AC square is equal to twice of AD square, which is the median square, plus BD square. Right? Now if I have to find this length B using that, I will take this side AB and BC. So AB square plus BC square is equal to twice of this length B, BE square plus AE square. Similarly, when I take this third median CF, so I should take this side AC and BC. AC square plus BC square is equal to twice of CF square plus AF square. Okay, AF or BF, whatever. Because we know these two sides are equal, these two sides are equal, and these two sides are equal. Now, if I add the 3 equations, just add the 3 equations, what will you get? 2AB square, 2AC square, and 2BC square, right? So, twice of AB square plus BC square plus AC square. So, AB square plus BC square plus AC square is nothing but sum of the squares of the sides. Am I right? So twice of AB square plus BC square plus AC square is nothing but sum of the squares of the sides. That is equal to twice of AD square plus BE square plus CF square. What is that? Sum of the squares of the medians. AD square plus BE square plus CF square is M1 square plus M2 square plus M3 square, which is sum of the squares of the medians. Okay, plus sum of the squares of the medians plus BD square plus AE square plus AF square. What is that? What is BD? BD is nothing but half of this side. So BD is nothing but half of BC. So BD square will be nothing but BC by 2 the whole square, which is nothing but BC square by 4. Right? So BD square is nothing but BC square by 4. So BD square will be BC square by 4. Similarly, AE square will be AC by 2 the whole square, which is AC square by 4. This will be AC square by 4. Similarly, AF is nothing but AB by 2. So, AB square by 4. Right? So, twice the sum of the squares of sides equal twice the sum of the squares of the medians plus BC square, AC square and AB square addition is nothing but again sum of the squares of the sides 1/4 the sum of the squares of the sides. So, this term is nothing but 1/4 or sum of the squares of the sides divided by 4. Clear? We're able to imagine this, right? So twice the sum of the squares of sides is equal twice the sum of the squares of the medians plus sum of the squares of the sides divided by 4. Let me take the sum of the squares of the sides for simplicity, right? Sum of the squares of, let me assume it is S square. Okay? And let me take the sum of the squares of the medians as M square. Okay? So this I can cancel this 2. Right? So S square equal to M square plus S square by 4. Is this clear? So here can I say S square minus S square by 4 is nothing but 3 by 4 S square. That will be M square. Therefore can I say S square divided by M square is nothing but 4 by 3. So what is S square? Sum of the squares of the sides. What is M square? Sum of the squares of the medians. Therefore, in any triangle, please remember, in any triangle, the ratio of the sum of the squares of the sides to the sum of the squares of the medians will be 4:3. Okay, say in case if they give you the sides of any triangle, they're asking you to find the sum of the squares of the medians, you can just simply apply this. So ratio of the sum of the squares of the sides to the sum of the squares of the medians will be 4:3. Medians to ratio of the sum of the squares of the medians to sum of the squares of sides will be 3:4. Please be careful in that. So if you have to just memorize this, side and median, always remember side is S is more than M. Okay. So or since you say in alphabetical order, M and O, P, Q, R, S, right? M comes first and S comes second. So 3 comes first and 4 comes second. Just to memorize this. So M square by S square is 3 by 4 or S square by M square is 4 by 3. Just know this. Now that is with median. Okay, centroid. Now let's go to the next geometric center, which is intersection angle bisector, which is Incentre. So centroid, intersection of medians is centroid, intersection of the angle bisector is Incentre. Let's go to Incentre now. Let's take a triangle. What is an intersection of the angle bisector? Okay, what's an angle bisector? You bisect this angle. Okay, so these two angles are equal. That's me. So let's say the triangle ABC, right? This line AD is the angle bisector, meaning AD bisects this angle, capital A, right? So the next angle you bisect this angle B. This is the angle bisector. So BE is the angle bisector and you bisect this angle C. CF is the angle bisector. Okay, the point of intersection is called as the Incentre. This particular portion is called as the Incentre, that is denoted by I. Now always remember with Incentre, so when I say Incentre, it's inside. So I can draw a circle with this center and that circle will be inscribed in the triangle. So if I have this as the center and I have this radius, or if I just with this center, if I draw a circle, okay, that circle will touch all the three sides. That circle is called as the incircle, and this radius of the circle is the in radius. Okay, now please remember this portion is not equal to Fi or Ei. Okay, that need not necessarily be the same. That is why I'm just drawing like this, assuming this is a scalene triangle. Okay, so this circle is the in circle and this is the in radius. Point of intersection of the angle bisector is in center. With in center I can draw a circle. Generally this in radius is denoted by smaller. You should know this notation. Okay, now just an extension in this, what kind of questions you can expect. So let's take this triangle. Same triangle ABC. Right. So if I ask you to find this angle BIC, I have to find this angle. This is I, right? But to find this angle BIC. Okay, how to find this angle? Now, since all these are angle bisectors, can I say this angle I'll assume it as small a and small a. This angle I'll assume it as small b and small b. This angle I'll assume it as small c and small c. Right? When this is c, this will be c. Right? So this total angle is 2b, this total angle is 2a, and that total angle is 2c. Now, here we know in a triangle, sum of the angles is going to be 180. So capital A plus capital B plus capital C is nothing but 2A plus 2B plus 2C. Therefore, can I say A plus B plus C is 90 degrees? Am I right? Because I know 2A plus 2B plus 2C is 180. Therefore, A plus B plus C is 90. Now I have to find this angle BIC. In this triangle BIC, can I say this angle is BIC, angle BIC, right? Angle BIC is nothing but 180 minus of B plus C, because sum of these three angles will also be 180. So angle BIC is nothing but 180 minus of B plus C. Now from the first equation, can I say B plus C is 90 minus A? I can replace this as 90 minus A. Right? So 180 minus of 90 minus A is nothing but 180 minus 90, which is 90, minus of minus A will be plus A. Therefore, angle BIC is nothing but 90 plus A. Right? Angle BIC, this angle is nothing but 90 plus small a. Right? Therefore, can I say angle AIC, this particular angle will be, right, 90 plus small b. If this is 90 plus a, this should be 90 plus b. Similarly in this, therefore, this angle, can I say it should be 90 plus small c. Right? So in Incentre, if I just have this as this angle made by the side with the Incentre, it will be 90 plus a. What is a? Half of the other angle. So this angle is nothing but 90 plus half capital A. Okay. So 90 plus capital A by 2. Capital A is the angle in the triangle. So on the other side. So this side, the angle made by the other two sides. Okay. So if this is 90 plus capital A by 2, this is 90 plus capital B by 2, this will be 90 plus capital C by 2. So therefore this three angles total will give me 390s plus capital A plus capital B plus capital C by 2. So this will be 390s is 270 plus capital A plus capital B plus capital C divided by 2, which is again 90. Therefore this will be 360. See, it is tallied. Okay, so it has to be true. Now in this triangle, if they ask with Incentre, this angle will be 90 plus half the other angle. You should know this with Incentre. Okay, Incentre, in circle, in radius. That's all. Now we will step into Circumcentre. What is Circumcentre? Intersection of the perpendicular bisectors. Okay. Now in a triangle ABC, what's a perpendicular bisector meaning? So when I say perpendicular bisector, it should bisect. So I'll take the midpoint. Now, for this point, I should draw a perpendicular line. Remember, for this point, I should draw a perpendicular line. Right? So if I just, this perpendicular will bisect these two. Clear? Right? Please note, this perpendicular line need not necessarily touch the vertex. Okay? So this is my perpendicular bisector. Similarly, for this side, I'll take the midpoint. I'll bisect this line. Right, so this is also perpendicular. This point of intersection. So I'll have the third one, midpoint. Just bisect this. These two are equal. This will also be perpendicular. This point of intersection is actually called my circumcentre, which is generally denoted by C. Okay, Incentre denoted by I, centroid by G, and circumcentre by C. Now, what is circumcentre? You can draw a circle. That circle is called a circumcircle. So, if this is the center, and if I am taking, say, this is my radius, so if C is my center, you just join this CA, CB, CC. Right, the circumcentre CC. This will be equal. So, with this, if I draw a circle, that will touch the vertices. Okay, this circle is called as the circumcircle, and this radius is called as the circumradius. Please remember, point of intersection of the perpendicular bisectors, circumcentre. With that, if you just join the vertices, all three will be equal in length. That will be the radius. So you can just construct a circle which is circumcircle. Right. So that's all with perpendicular bisectors. Okay. This is my circumcentre. So the center is circumcentre. Okay. Now the next thing is altitude. So what's an altitude? For any triangle, the height is called as an altitude. So you draw a perpendicular from the vertex. You draw a perpendicular. This height. So you'll have three heights. From this vertex, you draw a perpendicular. From this vertex, you draw a perpendicular. Okay. So triangle ABC. This is my first altitude, second altitude, third altitude. That's called as the height of a triangle. Nothing else with altitudes. Just you should know what is altitude. This point of intersection is called as the orthocentre. Okay. So that's all with my centroid, incentre, circumcentre, orthocentre. Now, we just saw how they are for an acute angle triangle. All the points are inside. Let's try to understand the geometric centers. Where will they be positioned for all different types of triangles, like acute angle triangle, right angle triangle, obtuse angle triangle. Now, my centroid, I'll write it over here. Then we have incentre. Then we have circumcentre. Then you have orthocentre. Right? No. For acute angle triangle, okay, we know for acute angle triangle, we know my centroid is going to be inside. Not only for acute angle triangle, even for right angle triangle, the intersection of median is going to be inside. Right, because you take the midpoint and you join, it will be inside. Okay, same goes for obtuse angle triangle. You take the midpoint and join, it's going to be inside. So acute angle triangle, right angle triangle, or obtuse angle triangle doesn't matter, because my center of gravity has to be inside any object. My centroid will be inside for any triangle. My incentre, again, since I have drawn in circle, incentre for any triangle. So let me have an acute angle triangle. Angle bisectors, it has to be inside. Right. So with this center, we'll draw a circle. The circle is in circle. Right. For right angle triangle, still my angle bisectors should be inside. With this, if I draw a circle, right, it has to be inside. Same thing goes for an obtuse angle triangle. Angle bisector has to be inside. With this center, you can draw circle. right? So my centroid and incenters will be inside for any triangle. Now, what happens to circumcenter and orthocentre? If I am taking a triangle, so acute angle triangle, circumcenter is intersection of the perpendicular bisectors. You bisect this, okay, then you take the midpoint, you bisect this, then take the midpoint and you bisect this, right? So with this you draw a circle. That's my circle. For a right angle triangle, same thing goes, right? If you just circumcircle, where will the center be gently? Okay, now how to bisect? So take the midpoint, or let me just have constructed this for you. So midpoint of right angle triangle, draw perpendicular, take this midpoint, draw perpendicular, and third side midpoint, it should be on the hypotenuse. That's the only point of intersection. Why? Because we know angles in a semicircle is 90. Using that concept also, we can arrive at this particular point. So for right angle triangle, my circumcenter will be exactly at the midpoint of the hypotenuse. Okay, because this length will be equal to this length. Right. For obtuse angle triangle, right, you take this midpoint, take this midpoint, take this midpoint. See, my point of intersection of the perpendicular bisectors is actually outside the triangle, right? Because this will be perpendicular, this will be perpendicular, and this has to be perpendicular. Okay, now if I construct a circle, this is how it goes. Okay, it's away from the longer side. So acute angle triangle, circumcenter is inside. Right angle triangle on the midpoint of the hypotenuse is on the hypotenuse. Obtuse angle triangle away from the longer side. Similarly, when I say orthocentre, okay, for an acute angle triangle, my height is going to be inside. This is perpendicular, perpendicular, perpendicular. Point of intersection of the altitudes. So for a right angle triangle, okay, this is my perpendicular line. Right, one. This is the perpendicular drop from here. So from this third point, if you draw a perpendicular, the point of intersection is on the point of where 90 is formed. It's again on the right angle triangle, on the point where 90 is formed. For obtuse angle triangle, okay, altitude. So for this point, you have to draw a perpendicular. You have to extend the side, right? So this is the side. Similarly, from this point, you have to extend this side and draw a perpendicular, right? Similarly, for this point, you draw a perpendicular line. You have to extend this over here. So my point of intersection is away from the smaller sides. So in general, if you just observe this, see, I am not mentioning the names A, B, C. It will be confused. Just understand this. My centroid and incentre for any triangle is inside. Okay. For acute angle triangle, all my geometric centers are inside, right? My circumcenter, also everything. Now, my circumcenter for right angle triangle is on the hypotenuse. Circumcenter for obtuse angle triangle is away from the longer side. Orthocentre is for the orthocentre for the right angle triangle is on the point where 90 is formed. Orthocentre for obtuse angle triangle is away from the smaller sides. Okay, just know this. Just to make it more specific for this circumcenter, if you just construct a circle, let me just explain it geometrically. Okay, let me take this circle here. Say if this is a diameter of a circle, right? So we know angles in a semicircle is always 90. Right? If I just join this angle is 90 degree. Right? Now if I bring this side to the bottom, say if I have the side over here, okay, Okay, if I have the side over here and the same point, if I just join this triangle, so this is my center, this triangle is an acute angle triangle, right? Now if I take this side to the top, and join this angle is say alpha, that is going to be an obtuse angle triangle. Therefore all this circle, this bigger circle, is actually the circumcircle for all these three triangles, be it the right angle triangle, or be it the acute angle triangle, or be it the obtuse angle triangle. But the center is here. So basically the center, right, for the acute angle triangle it's inside, for right angle triangle is on the hypotenuse, for obtuse angle triangle is away from the long side. Are you getting it? Just understand. That's why we say angles in a semicircle is 90, using that concept. Okay, now, so that's all with geometric centers of triangles. Now we will concentrate about only these two specific types. One is equilateral triangle, right angle triangle. You can expect questions based on this. So when I teach, I call this as history of an equilateral triangle or right angle triangle. Some concept is given, you should be able to do it. Let's start with equilateral triangle. Certain formula in equilateral triangle. Okay, what's an equilateral triangle? Equilateral triangle is nothing but all three angles will be 60 degrees and all the three sides are equal, right? This is my equilateral triangle. All the three angles are 60, 60, 60 and all three sides are equal. Now in equilateral triangle, if I just draw my median, angle bisector, perpendicular bisector and altitude, how will it be? Let me just construct a median here. So what's a median? You just take the midpoint. From this you just draw perpendicular from the vertex. Draw line. This is basically median bisecting, right? Similarly, I can just draw the median to this side. It's easy for you to understand when I use this proper. So similarly, I'll draw third median to this side. All the three meet at this particular point. Now, since it's a median, I know these two sides are equal. These two sides are equal. These two sides are equal. Right? Now, please observe carefully. Right? Since this total angle is 60, right? These two triangles, this median divides these two triangles, right? Now, this length, if this total length is A, right? This length is A by 2, this length is A by 2, right? So, every portion is A by 2, A by 2, A by 2, A by 2. Clear? Right now, this length, this is my point of intersection of the medians. If this length, since it's equilateral triangle, A by 2, this is A, this total is A, okay? This total is also A, this is A by 2. So can I say these two triangles, say triangle A, B, C, D is the median product. Okay, so triangle ABD is the same triangle ACD because they have the side A centimeter, A by 2, A centimeter, A by 2 and side. So yes, all three sides are equal. So they have to be congruent. I'll come to this congruency and similarity later, but you can just understand this here. So these two triangles are nothing but same. Therefore, this angle should be equal to this angle. So this angle is 30. This angle is also 30. Correspondingly, this will be 30 and this will be 30. Correspondingly, this will be 30 and this will be 30. Since in this triangle, if this angle is 30 and this is 60, it has to be 90. Therefore, this has to be 90. Right? Hence, can I say this AD is an angle bisector? It bisects the angle. Also, AD is perpendicular, so it's the altitude. Also, AD is bisecting and perpendicular. It's the perpendicular bisector. Similarly, my BE is the altitude, angle bisector, perpendicular bisector. My CF is also the altitude, angle bisector, perpendicular bisector. This applies only for an equilateral triangle where my median is the angle bisector, is the perpendicular bisector, is the angle bisector. Sorry, my median is the angle bisector, perpendicular bisector, altitude. Okay, all three medians. So for equilateral triangle, all are same. So this is my Incentre, Orthocentre, Circumcentre, Centroid. Okay, all are same for an equilateral triangle. Right, let's try to find the sides. So now, since this is my incentre, orthocentre, circumcentre and centroid, I can draw a circle which will be my incentre. Since this is my incentre, so this has to be perpendicular and I can draw a circle with this as the center. And this is the radius. Okay, right? Similarly, if I just draw a circle with this as the center, this is the radius. This is going to be my circumcircle. Clear? Are you able to imagine this? Right? So please, don't mind, it has to be perfect. Leave here. Okay. It has to just touch. Fine, and it has to touch here also. Right? So center. So this has to be my in radius, small r. This portion. This also small r. This also small r. Correspondingly, this will be our capital R. This will be our capital R. This will be our capital R. Are you able to figure it out? Because my incentre, circumcentre, orthocentre, centroid all are same. So this is my incircle, in radius, circumcircle, circumradius. So here, if this total length is A, this portion is A by 2 and this portion is A by 2, this total length is A. Now, in this right angle triangle ADC, right, using Pythagoras Theorem, can I say my length AD, which is the height, length AD, which is the height of the equilateral triangle, is nothing but a square minus a by 2 the whole square, c square minus b square. A square minus a by 2 the whole square is nothing but h square. Right? H square is nothing but a square minus a by 2 the whole square. So h equal to square root of a square minus a by 2 the whole square. If I simplify this, what will I get? Right? Height of the equilateral triangle is nothing but square root of, so this is nothing but a square minus a square by 4. So a square minus a square by 4 is nothing but 3 by 4 a square, 3 by 4 a square. So square root of 3 by 4 a square is nothing but root 3 by 2a. Am I right? Because square root of 3 by 4 a square is 4 comes outside, so 1 by 2, a square comes outside, so a by 2. So root 3 a by 2. Right? So height of the equilateral triangle is nothing but root 3 a by 2. My height is nothing but capital R plus small r. So my height is nothing but capital R plus small r. Sum of the circumradius and in radius. We know centroid divides the median in the ratio 2:1. Therefore, can I say my ratio of the circumradius to in radius should be 2:1. Right? So 3 parts is root 3 by 2a. Am I right? 3 parts is root 3 by 2a. Right? What is 1 part? If I divide by 3, 1 part is equal to root 3a by 2 into 3, which is nothing but a by 2 root 3. Correspondingly, what will be 2 parts? Double it, a by root 3. Fine. Therefore, my circumradius or circumradius of an equilateral triangle is nothing but a by root 3. My in radius of an equilateral triangle is nothing but a by 2 root 3. Right? So height of the equilateral triangle root 3 by 2a. My circumradius is a by root 3. In radius is a by 2 root 3. You should know this at any point of time. Okay. So for an equilateral triangle, side is a, in radius a by 2 root 3, circumradius a by root 3, height root 3 by 2a. From this one you can also derive area of the equilateral triangle. So we know for any triangle, area is nothing but half base into height. So area of an equilateral triangle is half, base is nothing but a, height is nothing but root 3 by 2a. Am I right? Half base into height. Therefore, the area of an equilateral triangle is nothing but root 3 by 4 a square. So, for equilateral triangle, when any one is given, say area is given, in radius is given, circumradius is given, or length of the median is given, height is given, side is given, you can find all other parts. Okay. So, height is root 3 by 2a, circumradius a by root 3, in radius a by 2 root 3, area root 3 by 4 a square. This you should have it in your fingertips. It's good to know that. Okay. That's all with history of equilateral triangle. Now, let's get into right angle triangle. something about right angle triangle. What is right angle triangle? So triangle A, B, C. This angle is 90 degrees. So when I say right angle triangle, the sides will be A, B, C. If I just have, you have some integral values called as Pythagorean triples or triplet. So the smallest integral value of right angle triangle is nothing but 3, 4, 5. Okay, just know this. 3 square plus 4 square is nothing but 5 square. So 3, 4, 5 is the smallest integral value of the sides of the right angle triangle. Okay, for right angle triangle, all three sides are integers. Right, the smallest right angle triangle will have 3, 4, 5. You cannot have any side less than 3. If that is the case, it won't be an integer. Okay, so 3, 4, 5. Since 3, 4, 5 are right angle triangle, 3, 4, 5 side. If the sides are 3, 4, and 5, it's a right angle triangle. Can I say all multiples 3k, 4k, and 5k will also be right angle triangles? K can be any integer. 3 into 2, 6, 8, 10. 3 into 3, 9, 12, 15. All these are right angle triangles. Okay, so you know one part, you can just, their multiples will also be right angle triangles. So 3, 4, 5 is the smallest integral value of right angle triangle. Now, what is the next number? So you should remember certain Pythagorean triples. So one is 3, 4, 5, then 5, 12, 13, okay, 7, 24, 25, 8, 15, 17, 9, 40, 41, and so on. Okay, how to know these things? I'll just tell you a shortcut or a trick to remember this. So, see, this is not for all possibilities. Certain values you can find. In case, we know for any right angle triangle, if I give you two sides, for any right angle triangle, if I give you two sides, you can definitely find the third side. If I tell you, if I give you one side for a right angle triangle, one integral number, you can tell the possible values of the other two sides. I repeat, you can tell the possible values of the other two sides. For example, when one of the smaller sides of right angle triangle, say 3, it's an odd number. It has to be an odd number or even number, right? When one of the side, forget about the hypotenuse, other smaller sides, okay? If it is 3, if it's an odd number, do this method, okay? Odd number, square it. 3, what is 3 square? 9. Separate 9 equally, 4.5, 4.5. Okay, since those two are non-integers, 4.5, 4.5, take this 0.5 to the next number, okay? 3 square is 9, square it, separate it equally, 4.5, 4.5. So, take 0.5 to the other number, so 4 and 5. So, 3, 4, 5 will be Pythagorean triples. You can apply this for any odd number, okay? Take some other odd number, say 5. 5 is one number, square 5, 25, separate it equally, 12.5, 12.5, therefore 12 and 13 will be Pythagorean triples. Say 7. Odd number, square it, 49, separate it, 24 and 24.5, 24.5, so 24 and 25. 9, square it, 80, separate it, 40 and 41. Okay? Right, this is, you can just apply for this odd number. In case, if you have one number is even number, let me take a number 6. If it's an even number, smallest is even number. Odd number, square it, space it equally. Even number, divide by 2. First step, okay? Divide by 2. What is 6 by 2? 3. After dividing by 2, square it. Okay? 3 square is 9. Plus 1, minus 1. No dividing. So, even number, divide by 2, then square it. 6 by 2 is 3. 3 square is 9. 9 plus 1, 10. 9 minus 1, 8. 6, 8, 10 will be Pythagorean triples. Say some other even number, say 8. 8 by 2 is 4. 4 square is 16. 16 plus 1 will be 17. 16 minus 1 will be 15. Say some other even number, 10. 10 by 2 is 5. 5 square is 25. 25 plus 1 is 26. 25 minus 1 is 24. See, look at this number, 10, 24, 26. Common number is 2. Knock off. You will get 5, 12, 13. See, 5, 12, 12, 13 is nothing but Pythagorean triple. So, it's one of the ways to remember these things. Say, if one side is 8, will that be, does it necessarily mean it will be 15 and 17? Need not necessarily be. It can also be 6, 8, 10. Okay, as I already told you, you can find one of the possible integral values of the other sides. Okay, and there are some values of Pythagorean triples. It's just good to know which cannot be applied using this. Say for example, you have 20, 21, 29. Just remember this alone in addition to these things. So most of the questions will be revolving around these Pythagorean triples. Okay, it's good to know this, right? So for right angle triangle, when you have sides, Pythagorean triplets or triples. Now let's take the other part. So right angle triangle, the sides are, let me say, A, B, C, right? So let me have this in circle. Okay, right angle triangle, this is my in circle, right? So this will be my in radius, smaller, smaller, smaller. Okay, now since in this portion, this is R and R, there are three 90s, so this fourth angle should also be 90, and these two sides are equal, therefore it has to be a square. So if this is R, this should be R, and this should be R. Am I right? Right, so this portion should be a square, R and R. So I'll have the balance portion. So can I say this length, because we know every side is a tangent to a circle, circle is inscribed now. So tangent from external point are always equal in length. So from one point you can draw two tangents to a circle that will be equal in length. Since this portion is equal to this portion. Am I right? Let me assume it as x. If this is x, this will be x. Similarly, this portion will be equal to this portion. Let me assume it as y. This is y, this is y. Okay. Therefore, there are three sides for this right angle triangle. So if I am just having it as A, B and C, I have A, B, C. A is basically x plus r. A is basically x plus r. B is nothing but y plus r. Y plus r. C is nothing but x plus y. X plus y. Okay. A is x plus r. B is y plus r. C is x plus y. Now, I need to find the smaller. From this, if I add the first two equations, what will I get? X plus r plus y plus r. I need to subtract x and y, so I can just subtract the third. Right? I have x plus r, y plus r, x plus y. So x plus r plus y plus r minus of x plus y, which is nothing but 2r. If I divide by 2, I'll get r. Am I right? Hence, can I say r is nothing but first equation, which is A plus B. I'll have 2r plus x plus y minus x minus c, which is 2r. Divide by 2, I'll get r. Right? So my in radius of a right angle triangle is nothing but sum of the smaller sides minus the larger side divided by 2. You should know this. For right angle triangle, in radius is sum of the smaller sides minus the larger side divided by 2. Now, what is the circumradius for right angle triangle? As you all know, my circumradius is nothing but, if I draw a circumcircle, okay, this is my radius. So this is going to be the diameter, the hypotenuse. So midpoint of the hypotenuse is nothing but c by 2. Right? So for right angle triangle, in radius is sum of the smaller sides minus the larger side divided by 2. Circumradius is the larger side divided by 2. You should know this. Next, let me take this right angle triangle 3, 4, 5 and try to understand something from this. So triangle ABC, this side is say 3 centimeter, this side is 4 centimeter, this side is 5 centimeter. Okay, can you tell me the in radius and circumradius? So we know it should be A plus B minus C divided by 2. 3 plus 4 is 7. 7 minus 5 is 2. 2 by 2 is 1. So it should be 1 centimeter each. So if this is 1 centimeter, 1 centimeter, this is 2 centimeter, 2 centimeter, this will be 3 and 3. See, it is tallied. Okay, what is my circumcenter? Midpoint of the hypotenuse. So this is my 2.5 centimeter circumcenter. Please remember, this point and this point need not necessarily be same. Which is 2 centimeter? This is 2 centimeter, this is 3 centimeter, that is 2.5 and 2.5. Therefore, this point need not necessarily be the same. Now, if I take this right angle triangle ABC, let's try to learn about similarity and congruency. Okay. First of all, before getting into it, what is similarity and congruency? Right, I have similarity and congruency. Now, similar, two figures are similar. Similar means look-alike. Okay, similar means like say two circles are always similar. Best example I can say, two circles are always similar. But when I say congruent, two figures are similar. Congruency means ditto, photocopy. Two circles with equal radii are congruent. Okay, two circles are always similar. Two circles with equal radii are congruent. Similarly, two squares are always similar. Two squares with equal sides are congruent. Okay, so when I say in triangles, similarity, two triangles are similar when their angles are equal. This angle is alpha, this angle is beta, this angle is gamma. In this triangle, I have the three angles. Okay, alpha, beta, gamma. So if three angles of two triangles are equal, they are similar. Say this triangle is ABC and this triangle is BF. This is going to be similar. So two triangles are similar. Congruency means ditto. But when I say angles are equal, remember the sides need not be equal. So this is one triangle, this is a triangle. Sides need not be equal. So okay, but the angles are equal, right? So these two triangles are similar. Angles are equal. I didn't comment about the sides. So when two figures are similar, their corresponding sides are proportional. What do you mean by corresponding sides? Corresponding sides means side opposite to equal angles. For example, here in the first triangle, I have the angle alpha, beta, gamma. First triangle, triangle ABC. What is the side opposite alpha? AC. What is the side opposite beta? AB. What is the side opposite gamma? BC. These are the corresponding sides. Second triangle, say DEF. What is side opposite alpha? EF. What is side opposite beta? DF. What is side opposite gamma? DE. Right? So corresponding sides are proportional. So AC by EF should be equal to AB by DF should be equal to BC by DE. Right? So if two triangles are similar, the corresponding sides are proportional. Corresponding sides is nothing but sides opposite to the equal angles are corresponding sides. Please note, you should not say AB by DE. Need not necessarily be, because AB is opposite beta, DE is not opposite beta. Okay, so opposite beta is DF. So AB by DF. Okay, now when two triangles are similar, it's not only corresponding sides, their in radius R1 by R2, circumradius R1 by R2, perimeter P1 by P2. Okay, or ratio of the heights drop to the corresponding sides, everything will be equal. Okay, it's nothing but say all are equal, say whatever it is. Right? Clear? It's not only that, the ratios will be equal to these two triangles are similar. To just go one step, the ratio of the areas will be square of this. So A1 by A2 will be square of this. It can be of anything. AC by AC square by EF square. Right? So ratio of the areas will be square. Sides means this. If I generate a volume with that solid, it will be cube. Let's see that in the mensuration chapter. Now let's not get into this. Just please note, two figures are similar. Corresponding sides are proportional. Okay. Remember, congruency means all similar figures need not necessarily be congruent. Please remember, I repeat, similar figures need not necessarily be congruent, but congruent figures are always similar. Okay, all congruent figures are similar, but similar figures need not necessarily be congruent. Now, you should have learned these in school. So we have triple S. Triple S is congruency. ASA, angle side angle, congruency. SAS, congruency. Triple A, similarity. Okay, what do you mean triplets? Three sides of two triangles are equal. All three sides, this side and this side. This is equal to this, this is equal to this, this is equal to this. Triplets, congruency. And ASA means angle side angle. So two angles and common side. So this side, two sides are equal, and angle, this angle, right? This angle, and say this angle. Right? AS A. Okay, this A, this side equal this angle, ASA. That is also congruency. SAS, side angle side. One side is equal, angle, included angle, and third side. These two triangles will also be congruent. This side angle. Triple A, similarity. So three angles need to be seen. It's similarity. So congruent means definitely similar. Similar means need not necessarily be congruent. This you should know. Now, let's try to understand this for right angle triangle. Let me take this right angle triangle. 3, 4, 5. Okay, 3, 4, 5. Triangle A, B, C. I want you to find the length of the perpendicular dropped to this right angle triangle. Length of the perpendicular dropped to the hypotenuse of the right angle triangle. Okay, this length. Right? I have to find this particular length. How to find this? Now I have three triangles here, right? Say ABC and let it be D. What are three triangles? ABC is the bigger triangle, ABD is the second triangle, and BDC is the third triangle. Are the triangles similar? Let's try to find it. So this angle is, let me say this angle is theta, or say x to make it. This angle is x, and say this angle is, say this angle is 90. This angle will be 90 minus x. Am I right? If this angle is x and 90, this should be 90 minus x. In this triangle BDC, I know this angle is 90. This angle is 90 minus x. Therefore, this angle should be x. And this total angle is 90. If this is x, this should be 90 minus x. Or in this triangle, if this is x, this is 90, it should be 90 minus x. Therefore, all these three angles are having their respective corresponding three angles is equal. Therefore, the three triangles are similar. So we know if three triangles are similar, corresponding sides are proportional. So in the first triangle, when I say I have triangle ABC and ABD and BCD. Okay, three angles, say x, 90 minus x, 90. Okay, right? So what are the corresponding sides? Let's plot it. So in triangle ABC, bigger triangle, what is side opposite x? In triangle ABC, side opposite x is 4. Clear? Triangle ABC, side opposite x is 4. In triangle ABC or triangle ABD, or what is side opposite x? In triangle ABD, side opposite x is BD. I don't know BD. In triangle BDC or BCD, what is side opposite x? Which is CD. Clear? Similarly, let's plot the other. In triangle ABC, 90 minus x. Triangle ABC, 90 minus x is AD. In triangle ABD, in triangle ABC, bigger triangle, 90 minus x is 3. Okay. In triangle ABC, side opposite 90 minus x is 3. And in triangle ABD, side opposite 90 minus x is AD. ABD, opposite 90 minus x is AD. And in triangle BCD, this bottom triangle, opposite 90 minus x is BD. Right? Now, in triangle ABC, opposite 90 is the bigger side, which is 5. In triangle ABD, opposite 90 is 3. In triangle BCD, opposite 90 is 4. Right? So we have this table. So we know two triangles are similar. Their corresponding sides will be proportional. So here we have to find all these unknown variables. We can actually find the unknown variables. So how to find that? Just equating those. So can I say 4 by BD is equal to 3 by AD, that is equal to 5 by 3. Similarly, BD by CD is equal to AD by BD is equal to 3 by 4. Or 4 by 3, that is equal to BD by AD, that is equal to CD by BD. I can say that also. Or 3 by 5 is equal to AD by 3, that is equal to BD by 4. So using this box, okay, this entire value, I can actually find the value of AD, right? Clear? Because 3 by AD is equal to 5 by 3, therefore AD is equal to 3 into 3 by 5. So can I say AD is equal to 9 by 5? So what is 9 by 5? So AD will be 1.8. So if AD is 1.8, using this equation, AD by BD is equal to 3 by 4, can I say BD is equal to 4 into 1.8 by 3? So 1.8 by 3 is 0.6, 4 times 0.6 is 2.4. Therefore, BD will be 2.4. Right? So if BD is 2.4, this is also 2.4. Right? So or using this equation I can find, or BD by CD is equal to 3 by 4, CD is equal to 4 into 2.4 by 3, 4 into 2.4 by 3 is 0.8, 4 into 0.8 is 3.2. Or I can say CD is nothing but 5 minus 1.8, 3.2. So using this similarity concept, we are able to figure out these unknown values in this right angle triangle, BD, AD and CD. From AD you can actually find it. Okay, so this is understanding this using similarity concept. Now same thing, without using the similarity concept, you can actually find this. Please listen this. Now listen. So here we know these three triangles are similar. So in this triangle, okay, so triangle ABC, can I say BD is the height of the right angle triangle? BD is one of the height, right? So BD is the height. Now area of this right angle triangle is half, area of this right angle triangle is half base into height, which is 3 into 4, which is same as half this base AC times this height, right? So area of the right angle triangle, if you consider this base, half base AC, which is 5, right, times height, which is BD. Therefore, equating these two, can I say, if you cancel 1 by 2, 1 by 2, H is nothing but 3 into 4 divided by 5. Okay, so the length of the perpendicular drop to the hypotenuse is nothing but product of the smaller sides divided by the larger side. 3 into 4 divided by 5 is 12 by 5, which is 2.4. That's what we got there. Right? So here 3 into 4, 12, 12 divided by 5, that will give us this particular value. Okay, so in a right angle triangle, if they ask you to find the length of the perpendicular drop to the hypotenuse, it is nothing but AB by C. Product of the smaller sides divided by the larger side. Okay, now from this concept, this is a right angle triangle. So I know this value, hypotenuse is 3, adjacent side is 2.4. Don't try to find 3 square minus 2.4 the whole square. Please listen. 3 and 2.4, what is common? Can I say both are multiples of 0.6? Yes. So I have 3, hypotenuse is 3, this side is 2.4. So knock off 0.6. This is 0.6 times 5. Am I right? This is 0.6 times 4. Right? So if this is 0.6 into 4, 0.6 into 5, this should be 0.6 into 3. Because 3k, 4k, 5k. So what is 0.6 into 3? 1.8. That's where we got 1.8. Similarly, in this triangle, 4 and 2.4. 4 is 0.8 into 5. Okay. Similarly, 2.4 is nothing but 0.8 into 3. Therefore, this will be 0.8 into 4, which is 3.2. Got it? So using my Pythagorean triples, I can actually find these unknown variables, or from the total you can just subtract. Just remember this, when you have two values and you can take one common term, using the Pythagorean triples you can find the other two values. Right? So that's all with right angle triangle. Maybe I can again call it as history of right angle triangle. Okay, so when I say history, it is not only from where it started, some data about those equilateral triangles and right angle triangles, the entire history. Okay, any small portion is given, you will be able to figure out the remaining portions. And one more thing which I would like to tell you here. So I told you about equilateral and right. Now in isosceles triangle, see if it's an isosceles triangle, let's say this is an isosceles triangle, right? So what is an isosceles triangle? These two angles should be equal and these two sides are equal, and this is basically my median, right? So if this is my median in an isosceles triangle, the median dropped to the base. I know this is the base is the unequal side, will be perpendicular, and it is already bisecting. Since it's isosceles, see, side angle side. Therefore these two triangles are congruent. Triangle ABCD, right? ABD and ACD are congruent. Therefore these two angles are equal. So my AD is my angle bisector, AD is my median, AD is my perpendicular bisector, AD is my altitude. Remember, for an equilateral triangle, all the three medians or altitudes, angle bisectors, perpendicular bisectors, and medians, angle bisectors, perpendicular bisectors, and altitudes for equilateral triangle. But for an isosceles triangle, only the median drop to the unequal side will be same. Will be the perpendicular bisector drop to the unequal side, will be the same altitude drop to the unequal side, and that will also be my median. So median, perpendicular bisector, angle bisector, altitude, all are same. But if you drop it to this equal side, okay, one of the equal side, if this is my median, this will not be my, or this will definitely not be my perpendicular bisector. My perpendicular bisector will be from this midpoint, you just draw like this, and my angle bisector will be somewhere like this. Okay, so only these three will be same, just remember that. For an isosceles triangle, this one will be same. That is one thing what you should know. Okay, that's all with triangles. Now we'll step into polygons. Right. What's a polygon? A polygon is nothing but a closed figure with certain number of sides. So triangle is a three-sided polygon. You have four-sided polygon, which is a quadrilateral. Five-sided polygon is called as a pentagon. Six-sided polygon is a hexagon. Seven-sided septagon. Eight-sided octagon. Nine-sided nonagon. 10 decagon, and so on. You have certain names. Now polygon, you have two types of polygon. One is concave polygon, right? Other is convex polygon. Okay, what is my concave polygon? What is my convex polygon? If I can draw you the figure, say this is a five-sided polygon. 1, 2, 3, 4, 5. It's concave polygon. This is also a five-sided polygon. It's pentagon. This is convex polygon, right? Okay. Or I can say the interior angles should be, if it's non-reflex. Okay, reflex angle is more than 180, right? Right. So if the interior angles are non-reflex, it's convex. If at least one is reflex, it is concave. Or the other definition can be, if you draw a line, if that line can divide the polygon into only two parts, it's convex. Okay, if you draw a line, if that line can divide the polygon into only two parts, it's convex. If a straight line can divide the polygon into more than two parts, it's concave. You can ask me, what if I divide like this? There will be two parts, but in this polygon, whichever direction you cut, it will be only two parts. Right? So here, using this cut, I'll get three parts, 1, 2, and 3 portions. That is my concave and convex polygon. Now we will not deal much about this concave polygon. We will only deal with this convex polygon. Now getting into this, right? So triangle, three-sided polygon. Quad, four-sided polygon. Pentagon, five-sided polygon. Hexagon, six-sided polygon. Right? Now, there is something called as regular polygon. Meaning, in a polygon, if all the sides and all the angles are equal, it's regular polygon. Like equilateral triangle is a regular three-sided polygon. Square is a regular four-sided polygon. Then you name these polygons as regular pentagon, regular hexagon, regular, and so on. Okay. Now, it's a triangle, quad, pentagon, and hexagon. If I, okay, let's come to this. Sum of the internal angles of a polygon. Okay, let me go to the next page. So when I say triangle, quad, let's have this around. Okay, sum of the internal angles of a polygon. How to derive? So we know for triangle it's going to be 180, and you know how it is 180. Okay, sum of the internal angles of triangle is 180. Sum of the internal angles of quadrilateral 360. Why? If I ask you, my quadrilateral can be separated into two triangles. So every triangle give me 180. So this 3 will give 180, this 3 is another 180, therefore 2 180s. My pentagon can be separated into 3 triangles. So 3 180s. My hexagon can be separated into 4 triangles. 4 180s. In general, my n-sided polygon can be separated into n minus 2 triangles. Therefore, sum of the internal angles of a polygon is nothing but n minus 2 times 180. Sum of the internal angles of any polygon is nothing but n minus 2 times 180. If I ask you, what is the each internal angle of a regular polygon? Of a regular polygon. That is equal to each internal angle. So we know for regular polygon all the sides and all the angles are equal. So each internal angle of any regular polygon is nothing but n minus 2 times 180 divided by n. Okay, so each internal angle of a regular polygon is nothing but n minus 180 divided by n. Right? Because we know all the angles are equal, therefore n sides you just divide by n. Now, you have something called as exterior angle. Say for a polygon, triangle. So you have external angle or exterior. So you have to just extend the side in the same direction. Clockwise means like this. Anti-clockwise if you just go the same side. Or if you just extend it in clockwise, if you are extending this side, then it should be like this and like this. Okay, you can't extend the same direction. Okay. Now this is called as an exterior angle. Right? Please note this. Sum of the exterior angles of any polygon is equal to 360. Sum of the exterior angles of any polygon is 360. Why? If this angle is say x, this angle is say y, this angle is say z. Okay, we know this total is 180, right? This total is another 180, right? This total is another 180. So linear properties. Okay, 180, 180, 180. So we'll have 3 180s. I know this triangle will be 180. All 3 interior angles will give me 180. So 3 180s minus 1 180 is nothing but x plus y plus z. That will give me 2 180s. 2 180 is 360. Okay, if it's a 4-sided figure, if it's a say quad, extend this like this. So you'll have 4 180s minus 2 180s, which is still 2 180s. 5-sided figure, 5 180s. Okay, pentagon. Extend. So we have 5 180s minus 3 180s is 2 180s. So sum of the exterior angle of any polygon is 360. Similarly, if I have to say sum of or each exterior angle each exterior angle of a regular polygon that should be 360 by n. That's it. So you should remember all these four formulae. Sum of the internal angles of any polygon is n minus 2 times 180. You know why? Because n minus 2 triangles. Each internal angle for regular polygon divided by n. Sum of the exterior angles of any polygon is 360 because you'll have n times 180 minus n minus 2 times 180 is 2 times 180. That's why 360. Each exterior angle of a regular polygon will be divided by n. That's it. Okay. So from if I have to find the interior angle of regular polygon, you can also use this exterior angle concept. For example, if I ask you to find the interior angle of a regular hexagon, using this formula, 6 minus 2, 4 times 180 divided by 6. So 4 times 180 divided by 6, which is nothing but 120 degrees, right? Each interior will be 120 if it's regular. Instead of doing this, I can say exterior angle is 360 divided by 6. So my exterior angle is going to be 60. So if the exterior is 60, interior will be 180 minus 60, therefore it's 180. Okay, you can use this exterior angle to find the interior angle of a regular polygon. That's all. This is with polygons. Okay. Now there are certain other types of quadrilaterals in particular. Okay, now triangle we know we have already saw. In quadrilaterals, certain types of quadrilaterals, let's see that one by one, the properties of those. So quadrilateral is nothing but a closed figure, four-sided closed figure. First thing, parallelogram. What is a parallelogram? Let me just use this. So this is a parallelogram. So in a properties of parallelogram. In a parallelogram, opposite sides are parallel and opposite sides are equal. That's it. In a quadrilateral, if the opposite sides are parallel and equal, it's a parallelogram. Okay. Now further, if I have to go to the properties, the diagonals of the parallelogram bisect each other. Okay, then my opposite angles are equal in a parallelogram. Opposite angles are equal, therefore adjacent angles are supplementary. Why? Because you have two parallel lines transversal, right? So we know these two angles are supplementary. Okay, that is why in parallelogram adjacent angles are supplementary, opposite angles are equal. Again, when I say supplementary, what is supplementary and complementary? So supplementary means sum 180. Complementary means sum 90. Okay. If two angles are supplementary, A and B, A plus B is 180. If two angles are complementary, A plus B is 90. That's all. Okay. For to memorize, C comes first, 90 comes first, S comes next in alphabetical order, so 180 comes next. So some people get confused between supplementary and complementary. Complement 90, supplement 180. Please remember that. So this is my parallelogram and properties of parallelogram. There is one extension to this. It's good to know this. So in a parallelogram, right, you take any point inside a parallelogram. Okay, you take any point inside a parallelogram. You join the four vertices. Let's say if this point is P. Say this is or ABCD. Right? So we have four triangles. Fine. So triangle 1, 2, 3, 4. Sum of these two triangles 1 and 3, sum of the areas of the two triangles 1 and 3 is equal to sum of the areas of the other two triangles 2 and 4. Okay, take a point. Sum of the areas of these two triangles is equal to sum of the areas of these two triangles. Okay, one more thing. You take two parallel lines and say this is the base of a triangle, say AB. Take a point C. Right? You take any point C, D, E and so on. The three triangles, right? AEB, AB is the base, ABE, ABC, ABD. The areas of all these triangles are equal. Why? Because, right? So the height is same, The height of all these triangles same, right? So ABE, ABC, ABD all are equal. Or I can say triangles formed between two parallel lines with the same base. With this base lying in one parallel on one parallel line will be of equal area. Half base into height. Height is going to be same. Also, this value, right, is equal to half the area of parallelogram. Okay, right? So when you say any parallelogram, you take a point, sum of these two areas equal to sum of these two areas, that is equal to half the area of a parallelogram. So when I say area of a parallelogram, how to find the area of a parallelogram? Again, there are multiple formulas for that. So you can take this triangle. So in this triangle, this is theta, this angle is theta, this angle is theta, right? So half AB sin theta, half this side is A and this side is B. Area of a triangle is half AB sin theta. So half AB sin theta. This triangle is also half AB sin theta because these two triangles are congruent. Diagonal divides the parallelogram into two congruent triangles, that you should know. So half AB sin theta, double it, which is nothing but AB sin theta. So area of a parallelogram is nothing but product of the sides into sine of the included angle. It's good to know this. Okay. So in general, if they ask area of a quadrilateral, you can just have the quadrilateral into triangles and rectangles if possible, or just draw a line. So here it's a perpendicular, this another perpendicular. It's a quadrilateral. Okay, this is not a parallelogram, just a normal quadrilateral, right? So here this is the diagonal. This is H1 for this triangle, H2 for this triangle. Half base. This diagonal is called as a base. Assume half base into H1, half base into H2. Sum you will get the area of a quad. Generally, this H1 and H2 are called as the offsets. Offset is nothing but the perpendicular dropped to the diagonal of a quadrilateral. Just know this term, okay? Offset. Okay, so they say area of a quadrilateral is nothing but half one of the diagonal into sum of the offsets to the diagonal. So offset is nothing but the perpendicular drop to the diagonal. Let's look at some other quadrilaterals like. Now, what is the difference between rectangle, square, rhombus? So all are actually parallelograms. So in a parallelogram, so this is a parallelogram. In a parallelogram, if the adjacent sides are equal, it's a rhombus. Okay? In a parallelogram, if the adjacent sides are equal, it's a rhombus. So rhombus is a parallelogram where all sides are equal. Rhombus is a parallelogram where all the sides are equal and the diagonals bisect each other at 90 degrees. Please note it. That's the rhombus. Now, in a parallelogram, if the angles are, all the angles are equal, it's a rectangle. In a parallelogram, if all the angles are equal, it's a rectangle. Rhombus plus rectangle, it's a square. If all the angles are equal and the sides are equal, it has to be a square. All angles are equal and all sides are equal. Okay, so rhombus is a parallelogram where all sides are equal. Rectangle is a parallelogram where all angles are equal to 90, and if its sides and angle equal, it's called as a square. Rest all properties applies. So looking at that area, volume, everything we will see in the mensuration chapter. Then you have trapezium. What's a trapezium? In a quadrilateral, if one pair of opposite sides is parallel, it's a trapezium. So here, assuming these sides are parallel, it's trapezium. These are non-parallel sides. Okay. In a trapezium, if these non-parallel sides are equal, okay, if these two non-parallel sides are equal, it's called as an isosceles trapezium. Okay, that's about it. And again, that need not be only inclined to say this is also a trapezium. These two sides are parallel, trapezium. Even this is also my trapezium. These two are parallel, it's also trapezium. Okay, please remember, parallelogram is the superset I can call. Subsets can be rectangle, rhombus and square. Or I can say all squares are parallelograms, all rectangles are parallelograms, all rhombus are parallelograms. Similarly, all squares are rectangles, but all rectangles are not squares. All parallelograms are not rectangles or rhombus or squares, like that. Okay, so that's about a four-shaded polygon basics. One more thing in a polygon, okay, in any polygon, diagonals. Okay, what's a diagonal in a polygon? We know in a quadrilateral we have two diagonals. Okay, in a pentagon we actually have 5 diagonals. 1, 2, 3, 4, 5. Triangle, 0 diagonals. In a hexagon, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. In a hexagon, we have 9 diagonals. Let us not draw all these things and count. So, in general, number of diagonals in a polygon is nothing but. So, first of all, what's a diagonal? Diagonal is nothing but a line segment joining 2 points on a polygon which are not adjacent. In simple terms, okay? Because if they are adjacent, that becomes a side. Okay? So, for me to have a diagonal, I need 2 points. So, in the n-sided polygon, I need to select 2 points. NC2 ways I can select 2 points. Therefore, there are NC2 line segments. From n polygon, I have to select 2, NC2. Now, from this NC2, I should remove the n sides. That's the number of diagonals in a polygon. Number of diagonals in a polygon is nothing but NC2 minus n. What is NC2? N into n minus 1 by 2. N into n minus 1 by 2 minus n. If I simplify this, we'll have n square minus n minus 2n divided by 2, which will be equal to n into n square minus 3n, which is n into n minus 3 divided by 2. Okay, all are same. Right? So, number of diagonals of a polygon is NC2 minus n or n into n minus 3 divided by 2. It's good to remember this. Now, we are stepping into the next part, which is circles. Actually, circle is a polygon with infinitely many sides. You can actually tell that. Okay, circle is also a polygon with infinitely many sides. Now, when I say in circle, you have right, understanding this. So we have diameter, chord, secant, tangent. These are the 4 terms I can say. So when I say diameter is nothing but the longest chord in a circle. Okay. If I have to define a chord is nothing but line segment joining 2 points on the circle is a chord. So here this is a chord. AB is a chord. Right. So if the center lies on the chord, it's called as the diameter. Diameter is the longest chord. Okay. Now, so if this is the center, this is also chord. Right. This is not the diameter, but it's a chord. So if the center, this is my radius, R. Always the radius are equal, and this will be an isosceles triangle. Okay, chord, if we join the center, it will be an isosceles triangle because radii are equal, therefore the angles are equal. Now, you know chord, what is a chord, what is a diameter? They have something called as tangent and secant. What's a secant? So secant is nothing but line segment, you extend a chord outside, it's a secant. Tangent is nothing but which touches the circle at one point. Say this is my tangent. So here PAB is a secant, whereas PT is a tangent. Right? Now, tangent is always perpendicular to the radius. Right? So this is my secant, this is my tangent. I can also have multiple secants and multiple tangents. See if I just, this is also my PCD. This is also my secant. Right? So PAB secant, PCD secant, PT tangent. From one point you can actually draw only 2 tangents to a circle. From one point you can draw only two tangents. If I see this is a point, see this is also a tangent, PT dash. Okay, right? So from one point you can actually draw only two tangents. So PT is the first tangent, P dash is the second tangent. From one external point you can draw only two tangents. Now there's something called a secant rule and tangent rule. PA into PB is equal to PC into PD, that is equal to PT square. Okay, PA into PB is equal to PC into PD, that's secant rule, that is equal to PT square, where PT is the length of the tangent, PA is this point, PB is this length, secant. PC is this, PD is this is PC, this is PC, this will be PD, right? Or let me have it as x and y, diameter be x and y, right? Because PAB, PC, D, that's it. Fine, just to understand everything, tangent, chord, diameter, circle, that's going to be. Now, how many, then you have types of tangent. You have direct common tangent, transverse common tangent. Okay, what's a direct common tangent? What's a transverse common tangent? Direct common tangent, transverse common tangent. Now, what is a direct common tangent? So, before getting into direct common tangent, transverse common tangent, let me tell you what's a common tangent. So, when I say common tangent to two circles, there is a tangent that is common to two or more circles. Okay, so for two circles, when I say how many common tangents can be drawn to two circles. So, how many common tangents can be drawn to two circles? That depends on how the two circles are positioned. So, if two circles are one inside the other, no common tangent. Right? Two circles, one inside the other, no common tangent. Two circles, one inside the other, but they're touching first circle, second circle. So, I'll have one common tangent. Right? Now, two circles that are intersecting, I'll have two common tangents. Okay. Now, two circles touching outside, we'll have three common tangents. One goes like this, other goes like this, and the third common tangent is inside like this. So you have three common tangents of two circles not touching, not intersecting outside. We'll have four common tangents. 1, 2, 3, 4. Clear? So two circles will have common tangents that depending on how the circles are positioned. Right? So you have 0 common tangent. 1, 2, 3, 4. Now in this, some are direct, some are transverse. So this is a direct common tangent. Here this is direct common tangent. This is direct common tangent. So here this is direct common tangent. This is direct common tangent. This green color is a transverse common tangent. Similarly here, this will be transverse common tangent. This will be transverse common tangent. These two are direct common tangents. Right? Now, what's a direct common tangent? If I have to tell definition, if I define it, if both these circles are lying on the same side of a tangent, it's a direct common tangent. If both these circles are lying on the opposite sides of a tangent, it's transverse common tangent. To make it simple, okay? If both these circles are lying on the same side of a tangent, it's direct common tangent. If both these circles are lying on the opposite sides of a tangent, it's a transverse common tangent. Now, we have to find the length of a direct common tangent, transverse common tangent. How to find the length of the direct common tangent, transverse common tangent? Let me have two circles, circle 1 and say circle 2. Right? Now we have to find this particular length of a direct common tangent. Now we'll have radius. This is my capital R for the circle, and this is the other radius, which is my small r. Okay, so if I have to find this particular, let me denote this as L. Right, now let me project this length. Okay, let me project this length just to top parallel. Right, so such that this length will be small r and this length will be capital R minus small r. Right, since this is my tangent, it's perpendicular to radius, so this is a rectangle, so this is my perpendicular. Now, so for me to find the length of the common tangent, we should know the distance between the centers. This is my center 1, this is my center 2. That's denoted as D. Now it's a right angle triangle. My length, this is nothing but this length. So length of the direct common tangent is nothing but d square minus r minus r the whole square root. Okay, clear? The distance between the center square minus r1 minus r2 the whole square root of, because using Pythagoras theorem. That's my length of the direct common tangent. If I ask you to find the transverse common tangent, same process. If the circle is over here, okay, right, please imagine the circle is over here. Let me just have it here. So length of the direct common tangent is nothing but dct, distance between the center square minus r minus r the whole square. Okay, distance between the center square minus r the whole square. Now transverse common tangent, this is actually transverse common tangent L. Now here my distance between the center square will become what? This. So here we have to project this line to the bottom over here, such that this will become small r. So now in this triangle, I know distance between the center square minus this will become r plus r. This total length is capital R plus small r. So it's a bigger right angle triangle. This will become r plus r. This is my d. This is my L. So d square equal to, or distance between the center square, L square equal to d square minus r plus r the whole square. So hence we have my length of the transverse common tangent is nothing but d square minus r plus r the whole square root. Okay, so just to memorize, you can say d square minus r the whole square, r plus r the whole square. Direct difference, that's why we have r minus r. Transverse t means it looks like plus, so we have r plus r the whole square. Okay, it's good to know this. So direct common tangent d square minus r the whole square root. Transverse common tangent d square minus r plus r the whole square root. That's it. Then you have two other theorems in circle, or just sectioning to it. So in circle, we know chord, and we have something called as arc. So length of that. So this, if I just have a chord, so AB, right, this portion is called as the minor arc, and say ABC, this portion is called as the major arc, right, and this portion is basically the sector. Okay, so we'll have something called as center of a circle. Okay, so this is my minor arc, this is my major arc, this portion is my sector. Now angle, so when I say in circle, if you just have a chord, angle made by the chord with the center, angle made by the chord with the center will be twice the angle made by the chord in the other segment. Okay, so if this is the chord making the center, the same in this segment. Okay, this is theta, this should be 2 theta. Angle made by a chord with the center. Okay, so if it's a minor arc, this is the angle made by this particular chord AB. It's making center. That angle will be twice the angle made by the chord in the upper portion. Similarly, if this portion is 2 theta, this has to be 360 minus 2 theta. This should be 360 minus 2 theta. And we know cyclic quadrilateral, opposite angles are supplementary. Okay, I didn't tell you about cyclic quadrilateral. So what's a cyclic quadrilateral? Basically, if a quadrilateral can be inscribed in a circle, it's called as cyclic quadrilateral. If a quadrilateral can be inscribed in a circle, it's a cyclic quadrilateral. In cyclic quadrilateral, the opposite angles are supplementary. Okay, opposite angles are supplementary in a cyclic quadrilateral. Rectangle is a cyclic quadrilateral, square is a cyclic quadrilateral. Then you can say isosceles trapezium is a cyclic quadrilateral. Okay, but this is not rectangle, not square, not isosceles trapezium, but this is also cyclic quadrilateral. Okay, so inside a circle, you just draw like this. It can be anywhere. Yes, this is cyclic quadrilateral, right? No. So using that, here we know this AB or ADBC is a cyclic quadrilateral. Opposite angles are supplementary. Semi-central angle. So this theorem is called as the central angle theorem. Angle made by a chord at the center will be twice that of the other portion. Now this is central angle theorem. Now we have, so the same thing, I can also say angles in the same segment are equal. So when I say this chord is making angle like this. This is also theta, this is also theta. Okay, angle made by angles in the same segment. Okay, this entire segment will be equal. If you have here, all these will be 180 minus theta. So central angle theorem is angle made by a chord in the center will be twice that of in the other segment. Okay, so if you take this segment, it should be this particular angle. And angles in the same segment are equal. Then you have one last theorem which is going to be alternate segment theorem. So what's alternate segment theorem? Angle made by a chord with the tangent. This is a tangent. Angle made by a chord with the tangent is equal to the angle made by the chord in the alternate segment. Okay, I repeat, angle made by a chord with the tangent is equal to the angle made by the chord in the alternate segment. This is alternate segment theorem. So if you have any angles, all these are theta. From this, if you have to implement the central angle theorem, if this is the center, this will be 2 theta. That's all. So this is my alternate segment theorem and central angle theorem. So circles, when they give certain angles, you should be able to apply these 2 theorems and get the answers. With an extension of this, if I have to explain using a right angle triangle inside a circle, so we know, see, circle, this is my diameter, right? So we know angles in the semicircle is 90, right? Angle made by chord, this is a chord, okay? So angle made by this chord is making an angle which is 180 with the center. Angle made by a chord with the center, which is basically 180. That will be twice that of this. Similarly, if you have here, this is going to be another 180. This also 90. That is why angles in a semicircle is 90 degrees. Just to understand that part here. Okay. So this covers the entire geometry. Almost 90-95% of the geometry I have just explained it to you. Please watch this video. And I know it's a very long video. I've tried to just explain every concept to you. In case if you have any doubts, you can always post in the comments. I'll try to cover up in my next part. Or you can just verify your textbooks, everything. And the next portion we'll step into mensuration part, where we'll deal with area, volume of different figures and so. Right? Please pause the video and try to understand the concept before you go to the next concept. Okay.